Hey everyone, in this video we'll be learning how to solve simultaneous inequalities. Basically we're just looking at one variable for each inequality instead of, sometimes you can have like two variables in one inequality. So it's kind of very similar to how you solve like simultaneous equations, but now we're just looking at inequalities. Alright, so let's start off with a rather simple example. So let's say we have x satisfying x plus 2 bigger than 3, and then we also have x minus 3 less than 4. Alright, now the whole idea is that your answer, right, would be a range of values, right? Because you're dealing with inequalities, it is likely to be a range of values. And this particular range of values for your x would have to satisfy both x plus 2 bigger than 3 as well as x minus 3 less than 4. So whatever the case is, right, you cannot just have satisfying just one equation but not the other. Alright, ultimately your answer must satisfy both equations at the same time and hence simultaneously. So let's just solve for each inequality before we can find a range of values. So on the left we have x bigger than 1, right? Plus 2 bring over become minus 2. On the right we have x less than 7, right? Minus 3 bring over become plus 3. So there we have it, right? We have two conditions for x. It must be bigger than 1 to satisfy the equation on the left. It must be less than 7 to satisfy for the equation on the right. So one way to do it, which is to use your number line, right? One way to visualize it is to use this number line. So we have 1 on the left, 7 on the right. So to satisfy the first equation, it will be like this, okay? So x greater than 1. To satisfy the right equation, again, less than 7, so therefore from here. Now the whole point is that where do they overlap? And that would be the final answer. So therefore where they overlap, which will be this bar over here from 1 to 7. Alright, so to put it better, I'm going to use the circle, empty circle at each end. As such, we know that if x had to be greater than 1 and less than 7, therefore the final answer that satisfies both inequalities at the same time will be x greater than 1 and x less than 7. Now, if, let's say, we have another example, now we involve quadratic equations, okay? So let's say we have x squared minus x minus 2, it will be greater than 0. Then we have x greater than, so let's say x minus 1 greater than 1, alright? Let's say, maybe let's change it to greater than equals to 0 for the first one. So basically, if, you've learned from the previous video, right, you just need to simply factorize it to give us x minus 2, x plus 1 bigger than or equals to 0. On the left here, on the bottom rather, we have x greater than 2. Okay, now from here, right, if you're going to draw your quadratic graph, right, to solve this equation here. Otherwise, with enough experience, you know that this will result in x greater than or equals to 2 or x less than or equals to minus 1. Okay, now what do you notice? Now you have three inequalities, right? But actually, there's two possible solutions, right? You have x greater than 2 and x greater than or equals to 2, or x less than or equals to minus 1. So you don't have to consider all three inequalities actually. You just need to see which ones overlap, right? The idea is that there's, for the first equation, you have x greater than or equals to 2 and x less than or equals to minus 1. Which of these will overlap with the remaining inequalities? Alright, so let's say we notice that we have x greater than 2. Here we have x greater than or equals to 2 and x less than or equals to minus 1. Clearly, x greater than 2 will not overlap with x less than or equals to 1. So we can kiss this solution goodbye. And what we notice that to solve both inequalities, x must only be greater than 2, right? Because if x equals to 0, you are unable to satisfy the equation at the bottom, the inequality at the bottom. As such, the final answer is x greater than 2. Okay, so do take note, right? The idea of solving simultaneous inequalities is basically the overlap, right? Or the intersection between the inequalities. Okay, so that's pretty much how we solve simultaneous inequalities. So yeah, a pretty simple technique. So yeah, that's it.